Hello people, today we're going to talk about how to graph quadratic functions, and there's some steps that we're going to go through to do this. We're really going to use those characteristics that we talked about in our previous video that'll help us with graphing. And the reason why those characteristics are going to help us is, we talked a little yesterday, parabolas are the shape that quadratics take. And we want to be specific about the inputs that we're using, because you could always, whenever you're graphing, use a little table like this. But the important thing is choosing the right input values, because if you chose 5 input values like this, that look like that, your graph, when you graph, would just look like that. And that's not what we want. We want to show this curve. So we really need to find out where the center, like that axis of symmetry is, so that we can choose points on the sides, and then we can really see the shape of the graph. And that's why we're going to go through the steps that we have. So the first step that we have is that we are going to first find the equation of the axis of symmetry. And once you find the equation of the axis of symmetry, wherever it may be, the important thing here is that, let's say the axis of symmetry is right here, is we know that's like the center of the parabola. We don't know exactly where it's going to be. It could open downward, it can open upward. Our vertex could be higher or lower, but we know that's going to be the center, and we know that we're going to see that curve in the graph. We're going to see the parabola. After you find the axis of symmetry, you'll find wherever the vertex is. We can use the equation to see if it's going to open upward or downward. So after you find the axis of symmetry, we'll use the y-intercept. The way we can use the y-intercept is, once you know what it is, which it should be really easy to find in standard form, you can use symmetry to map a point on the other side. Like if the y-intercept is 2 units away, then you know 2 units away on the other side there'll be a point at the same height, and that can make graphing go twice as fast. And then we'll do the same thing by like finding other points. Like if we find a point right here, then we can use symmetry and we're going to know it's going to be the same distance away. And then we'll just connect everything with the smooth curve. And then we'll have a parabola. So let's go ahead and jump into an example of this. And I'm going to pull out a graph here. Let's just go like this. So our first one, we have the equation y equals x squared plus 4x plus 3. So first step, we want to find that axis of symmetry. And to do that, we're going to have x equals the opposite of b, which is -4, over 2a, which is 2. So x is equal to -2. That's your axis of symmetry. So I'm going to go to x equals -2 over here. That's right there. And I'm going to go ahead and draw my best axis of symmetry. X equals -2. From here, we can find the vertex of the function. We know x equals -2 is our axis of symmetry. So I'm going to plug that into the equation. Our vertex, we should know, is going to open upwards, so we'll have a minimum at x equals -2. We just need to find the y value. To find the y, just substitute in -2 squared plus, what's that going to end up being, -8 plus 3. -2 squared is 4, plus 3 is 7, -8, -1. So there's your vertex. Minimum at -2, -1. So right here, we know it's going to open upward, so we should be expecting the graph to look like that. Going up, that upward U-shaped parabola. I like to use the y-intercept. So the y-intercept from our equation is 0, 3. So go to 0, 1, 2, 3. And now we can use symmetry. The y-intercept was 1, 2 units away. So if we continue, 1, 2 units away, that will be a point on the parabola. You could also plug in 1, 2, 3, -4 in here, and you're going to find out that you get the same output as 3. So those two are together. And since we're 2 units away, I'm going to test to see if maybe 1 unit away was a nice point for us. So I'm going to take x is -1, and I'm going to substitute that in. And if I know what x is -1 is, since that's 1 unit away, I'll also know what it is when x is -3, because they're both 1 unit away from that axis of symmetry. So if we put x is -1 into this function, you'll have -1 squared minus 4 plus 3. -1 squared is 1, minus 4 is -3, plus 3 is 0. so -1 goes to 0. And since they are the same distance away, if we had a little table going here, since -2 is our center, and it's -2, -1, our -1 is 0, that means our -3 is going to be 0 as well. They're both the same distance away from that axis of symmetry. That's how the symmetry works in a table, is you're both the same distance away, so you have the same value. So we have right here and right here, that's 2 more points, and you can see the parabola starting to take shape, and we're opening upward. Here's our minimum value, and we're going to come back up on this side. So this would be the shape of our parabola for this function right here. And just like that, we are all done with our first example. So we'll hop into a second, and then you can go try some of these on your own. Alright, our second example, we have the function y equals -2x squared plus 2x minus 1. Alright, first step, let's find that axis of symmetry. So axis of symmetry is going to be x is the opposite of b, which is -2, over 2a, which is -4. So your axis of symmetry is x equals 1/2. So on this guy, we're going to go 1/2. And this is what your axis of symmetry will look like. X equals 1/2. Now let's go ahead and find our vertex. We open downward, so we're going to have a max at 1/2. We need to find the y value. So to find the y value, let's go ahead and substitute in. Y equals -2 times 1/2 squared plus 2 times 1/2 minus 1. 2 times 1/2 is 1 minus 1. This whole thing's going to cancel out, so we're going to end up with a 0 over there. So we just need to simplify this part. 1/2 squared is 1/4, so -2 times 1/4. Y will be, well, this is going to cancel, 2, so y is -1/2. So that means our vertex is 1/2, -1/2. And we know it's going to be a maximum value. So that means we're going to open downward. So let's go ahead and take our y-intercepts. Y-intercepts, y-int. That is 0, -1, 0, -1. And it's kind of tight here, but you're half a unit away. So you're going to be half a unit away on the other side. There's another point. And I'm going to go out a little bit. If we go to like x is 2, that would be 1.5 units away, which would be like x is -1 on this side. So those would be the same distance away, this x and this x and this x. So let's find out what happens when x is, we'll do 2 for this one. So when x is 2, 2 squared plus 2 times 2 is 4 minus 1. 2 squared is 4 times -2 is -8 plus 3. So y is going to be -5. So when x was 2, y is -5. And on the graph, that looks like 2, -1, 2, 3, 4, 5. Now in relation to your axis of symmetry, you're 1.5 units away. So you need to go 1/2 and 1 unit further. And that will be 2 new points. And right from there, we can go ahead and draw our parabola. Make sure it's a nice curve. And we are graphed. That's what the parabola for this one looks like. So go ahead and try some of these on your own. Graphing them. This takes a little bit of practice, but it's mainly about finding those characteristics. The characteristics are big because you want to know the special parts of the graph. A lot of times with word problems, you'll look for maximum values, or you'll look for like where you're crossing the y-axis. Really, the x-axis becomes really big when you cross the x-axis. We call those roots. We'll talk about those more tomorrow, though. Alright, guys, so go practice. Have a good day.